All right, welcome everybody to another beginner talk series. This is networking one. I think in the spring we'll have networking two, which will go a little more in depth. And also, I'm kind of taking a more like practical, high level approach to this. And if you want a more in depth like introduction to lower levels of the networking stack, then there are some great slides on our ISSS GitHub from a previous officer that made a talk last year that was a little more in depth on some of the technical details. But we can just get started here. So first I will picture this scenario, okay? You're a business comp sci double major. You're thinking Bitcoin is going to change the future, okay? So you want to show employers how much you love Bitcoin. The only way to do this, okay, is to make a blog. This is the most important thing when you're a business comp sci double major, is making a blog that talks about something random that no one's ever going to read. So like if you wanted to set up a blog like this, okay, how would you even do this? Besides just going to like Squarespace and just like paying them $5 a month or whatever to have your own blog, how would you actually set this up yourself? Like you need somewhere to store the posts and comments and stuff. And so you need a database server, basically, just like persistent storage. And then when people actually make requests to your website, you need a web server now to handle all those requests. And then you want a cool domain name, of course, like 2020.com is available, only like $5,000 a year, or Bitcoin is going up.com, that one's available too, so that people can actually find your content online. So like if you wanted to get started and you wanted to set up your database server, you might be thinking like, oh, okay, I get what a database server is. Okay, I got my web server, I got my database server, and they talk to each other. That's how it all works. But what does that even mean? Like, what does it mean for your web server to talk to your database server? And what does this picture like actually represent in terms of the actual networking stack? So to preface this explanation, I'm just going to say this is not an EE club. This is a CS club. So I'm going to skip over all of the really interesting stuff like electrical signals and stuff like that, and just skip to, we have computers and they're connected by some means, okay, and we can send bits back and forth. So if we have two computers that are connected like that, how would we actually communicate between them? So like, what does your computer do? It just like sends English text and just like, can you send me some data, please? But like, basically your computers, they need to be speaking the same language, right? If they're just sending data back and forth, then there's no way to distinguish what it means at all. And so communicating between different computers requires that we agree on a shared language, basically, which are called protocols. And if we wanted to actually have multiple computers to talk to each other, right, like the internet or something, we don't have enough wire to just like connect every single computer to each other. And so we need some way to go from one computer to the other without having a direct connection between them, which means that we need intermediate things, okay? And those are called routers, basically. And so each computer doesn't have to be connected to all the other computers. It can just be connected to the router. And then the router can be connected to other routers. And now you don't have to have direct connections between everything. You can just go to one router, hop to the next one, hop to the next one, and then reach your destination. And then second of all, once we try to send a message in this framework now, because we don't have direct connections between all the computers. So we can't just, if we want to send a message from the computer on the left to the computer on the right, then we can't just send it down the right wire. We just have to send it to the router. But how does the router know who to send it to? We need like some address basically for each computer. And so those are basically IP addresses, right? And so if you have a network like this, then the router basically helps all the computers assign themselves IP addresses so that they can talk to each other within the network. And then the hard part, okay, especially for CS majors, is actually talking to each other. So if we actually send data to a computer, another computer, what do we need to include so that the other computer can read the message, understand what it means, and interpret it correctly? So obviously we need like the sender and the receiver's address so that the router knows who to give it to, And we need the sender's address because the receiver needs to know who to send back to if it wants to reply. And we also need to know how long the message is, right? Like if the receiving computer just gets a bunch of data, it doesn't know which parts of the message are actually data, which parts are from like one application versus another. So we need to know how long the message actually is. And then we also need to know which message this is in the sequence. And that seems kind of weird, right? Like I'm just sending a message directly to the computer. But one of the things about the internet, especially when we get going to bigger scales with networks, is that things have the potential to be reordered. And so a lot of times protocols will have like a sequence number, which tells the receiving computer which message this was in the sequence, because sometimes the third message might accidentally arrive before the first one. And we also need to know some way of which program should get this message, right? Because if your computer just gets a million messages, it doesn't know it wouldn't know which program to send it to. We need some way of distinguishing this message should go to this program, this message should go to this program. And so these all correspond to some field basically in the packets, which are just the data that's getting sent to the computer. So like the sender and receiver address is just the source and destination IP. So like the source IP is just the sender's IP. So like if your computer sends a message, that's the source IP would be your IP. And then the destination IP is the computer you're trying to send to. And then how long the message is just a size field in a packet header. And then this one is just a sequence number. So if you're providing like reliable delivery, so like you guarantee things will be in order. So like protocols like TCP, they'll have a field called sequence number, which helps computers do this. And then the way that higher level protocols distinguish which program should get a certain message is by something called a port number. And this is just a convention created by the operating system and higher level protocols in the network, right? And so when your computer sends a message to another computer, it can specify a port number, and that tells the other computer which application should get that message. So like if I want to send a web request to a server, I specify the port as 80, and that's just convention for HTTP, which is just the web networking protocol. And then once we have a way to communicate between computers, we need a way to actually get to the server, right? So we show that diagram of like an internal network where everything's directly connected to a router, and the router just said, you're this IP, you're this IP, and then now we know how to send between the computers on the network. But if we're not on the same network as the web server, it's a bit more tricky, right? Like your computer is on one network and the web server is on another one, and they each have their internal addresses. So like you might have the same internal address as the server does, but you're on a completely different network. So those addresses are meaningless. So we need some way to distinguish like on a large scale on the internet scale. And so the way you actually address things on the internet is with a public IP, which is just like your public address, right? That's just saying this message needs to go here. And the thing about public IPs is that they need to be unique, right? Because if you had multiple computers with the same public IP, then when you send a packet through the internet, it has no idea, should it go to computer A or computer B? So these need to be unique. And so basically those are just going to be assigned by your ISP and like your internet provider. And then basically they get those IPs from even higher level governing bodies, basically. And then so like a super high level governing body that governs the internet distributes IPs among companies and internet service providers. And then those trickle down to like individual computers. So like your ISP will say your internet connection gets this public IP. And so basically they just get, it's a hierarchical thing like that. And so that was a lot of info. So let's just recap what we came up with. So we have a web server and a database server, and they're connected by a router, let's say. So they each have local IP addresses. So this is what local IP addresses usually look like. Usually like 192.168.0 or .1 or something like that. And so these servers can talk to each other, right? So if your web server wants to add something to the database, it can do that by sending packets to the router, which sends it to the database server. And then if you want to access the web server externally, you also have a public IP for your router. And so if you want to send a message to the web server like, can you show me the site? I want to see your site. Then you'd send it to that public IP, it would go to the router, and then the router would forward that to the web server. And then the web server would be like, okay, I got your request. I'm going to reply. And it sends a reply to the router. And the router will forward that to the internet, which is just a bunch of routers basically. And then those routers will just keep sending it back until it gets back to your computer. So to move on from actually how computers talk to each other and the basics of the internet, we need to talk about domain names as well. Okay, because so far we've only talked about IP addresses. And when you go to Google something, you're not sitting there typing in 172.217.1.238. It's not like something you just like memorize. Domains are basically just a way for humans to memorize addresses more easily than just a random IP like that. And so the domain name system basically just allows people to register a specific domain name like google.com with a domain name server, which just has translations from domain names to IPs. And so if I want to go to google.com, then I talk to the domain name server and I say, I want the IP for google.com. And then the domain name server will give me back the IP for that server. And then my computer, once it has that IP, it can go talk to that server because it knows its address now. And so to put that all together, your computer's connected to the internet, which is just basically a big collection of routers. And there's a domain name server. So if I want to go to the Bitcoin blog, then I'll ask the domain name server, what's the IP for bitcoinisgoingup.com? And it'll reply with the IP address for that web server. And then that gets sent to my computer. So my computer now knows the IP address of the blog website. So then it will send a packet to that IP, and that will go to the router, which then gets forwarded to the web server. And then the web server will be able to communicate with the database server so that when I post a comment or something to the web server, it can talk to the database server and vice versa. And then when the web server replies to my computer, it'll just send a packet to the router, go through the internet, and make its way back to my computer. So maybe the more interesting thing about networks, especially for us, is how do we attack networks? So now we know kind of the basics of networks. What are some of the ways that we can actually attack them? And so first of all, it makes sense to talk about the goal. So the cool thing about networks for attackers is that just given like a domain, okay, just like google.com or something, we can get a lot of information from that. And so basically we want to take some small piece of information like this, like just a domain name, and we want to turn it into a lot of other information that we could use to possibly attack the target, right? So if we wanted to like attack a specific organization or something, we could just go from knowing a domain name to finding out a bunch of information about them and finding different things that we could attack. So this is kind of equivalent to like a piece of software, right? Like if we wanted to attack a specific piece of software, one thing we want to do is gather information about it, right? So where can we give input to it? How many different places can we put input into it? And that's basically called the attack surface, which is just how many things can we do to the program or how many things are there that we can manipulate. And so this process of enumeration is just finding out the attack surface of the victim that we want to attack, right? And so in this case, for networking, that starts with we have a domain, and then we want to take that domain and figure out what are all the computers on the internet that the victim owns, basically. And so I want to go from a domain to those computers' addresses. They're just their IPs. And then once we have their IPs, we can start checking if they have certain software installed on them, which are talking to the internet, right? Like if they have web servers installed on them or databases, or they could have Minecraft servers or something, for instance. And then once we know that they have some software, we can look up that software and say, oh, that they're using an outdated version of this web server, so it has a vulnerability where I can break into their computer basically over the internet. And so the high level overview is that we'll take like a small piece of information, enumerate the victim, find more information about them so that we can look at what services they're running, what software they're running on their computers that are connected to the internet. And then over the internet, we can exploit that software. And then that will allow us to remotely execute code on their machines. And then from there, we can do anything we want, right? We can hijack their Minecraft server. We can start a Bitcoin miner, whatever you want. So the first step is how do we get from this domain to finding out IP addresses owned by an organization? So like if we looked up www.utexas.edu, we get an answer from the DNS server, right? The DNS server will just tell us that domain name corresponds to this IP address. And then we could go visit that IP address in our browser, or we can just put in the domain name in our browser and then it'll tell us the IP address for that server. But then we only have like one IP address, right? Like, okay, cool, we found one machine that University of Texas owns. But there's even more things we can do. So when you register a domain, you put in your contact information. And so, for example, if you look up utexas.edu, there's a whole system associated with the domain name system called the WHOIS system. And this allows you to, given a domain name, you can find out more information about them. So for instance, we put in utexas.edu here, and then it'll give us all the contact info for the person who registered that domain. And so here we can take like this email, for instance, and we can do the opposite. We can start with contact info and look for domains associated with that. So in this case, we just plugged in that email that we found, and then we looked up domains that are associated with it. So there's all these weird domains that are owned by that same email. So they're probably owned by UT as well, like elonghorns.com. I'm sure they bought that in like 2000 when the .com bubble was happening, and they're like, we got to get all the domains, or they have 92longhornboys.com. Not sure what that one's for, but. And then another thing that we can do to enumerate more information about an organization is related to autonomous systems. So one of the things about the internet is that it's organized hierarchically. So when your router wants to send a packet somewhere, it sends it to basically a bigger router. So like, you know how you're in your network, your machines are only responsible for talking to the router. So then at that next layer of the pyramid, basically, there's all these other networks. And so you have routers that want to talk to each other. And so how those routers talk to each other is they have a higher level router, okay? And so basically the internet is like a hierarchy of these routers, and the routers progressively get like have more and more responsibility. And so towards the top of the levels, they basically block out IP addresses, which makes it really easy for them to route traffic. And so what that basically means is like an organization will get the first like 64 IP addresses in some range. Like they'll get 192.168.1.30 all the way to like 1.94 or something. And so we can actually use that system to look up, start with like an organization and like the name of the organization, and then find IP blocks that they own. So like if we look up University of Texas in the autonomous system database, then we can find a bunch of different autonomous system numbers. And those are just the IP blocks that are registered to that organization. So like UT has clearly has a bunch of different autonomous system numbers registered to it. And then once we have these numbers correspond to IPs, blocks of IPs. So we can look up each number, and then that'll tell us for this autonomous system, for example, this one that UT owns, there's 65,000 IPs in here. And so you can see that like this net block field, for instance, that tells you they own 129.111.0.0 all the way up to 129.111.255.255. They own all the IPs in between there. And so the basic idea of the WHOIS and the autonomous system numbers is that we can, starting from a small amount of information like a domain name or something about the organization's name, and we can find a bunch of IP addresses associated with that organization. And then one thing to basically what I was talking about earlier with blocks and subnets, this is just an illustration of that. So like they own all the IPs in this range. And so these IPs may or may not correspond to an actual computer. Right? Like they might be running a web server on a couple of these IPs or a database server like we have here. But sometimes like some of these IPs might not be used. There might not be a computer associated with that IP. So if we try to send a request, we just won't get anything back and our request will time out. So the next problem is how do we narrow down from all the IPs that we came up with, how do we figure out which ones are actually running anything? Which ones are actually have a computer tied to them? So that process is called host discovery. So from our computer, we want to basically request each of these IPs. And there's a specific protocol that lets you basically ping, like if you've ever done like ping and then an IP or something to check if a server is up or something, or check how fast your internet is, then you can use the same trick basically to check if a host is alive, if there's a machine tied to that. So usually you can ping an IP, and if it sends something back to you, then that means the computer is alive. But in a lot of cases, you'll ping an IP and you won't get anything back because there's no computer behind it. And so this makes it kind of nice for us because we can just go through and ping all the IPs that we've seen, which is pretty fast. But one of the more tricky things is that organizations realize that. And so a lot of firewalls, for example, will, if they see a ping request from like an unrecognized IP address, then they will intentionally just drop it. So we can't do this trick sometimes. Sometimes we have to do some extra fancy stuff to see if there's actually a machine there. So the next part of this talk goes beyond just looking at publicly available information and stuff and goes into port scanning and service exploitation, which is not allowed on networks you do not own specifically. And the law isn't very clear on this, but historically in court cases, courts have come down extremely hard on people who use these techniques basically on router or on networks they don't own. So if you're doing this, only do it on networks you own. Be really careful about this unless you have the express permission of the other person who owns the network. With that being said, okay, we'll move on. So once you have like an idea of this IP address is alive, there's actually a machine there, what's the next step? So we found an IP and we want to see what's running on that IP basically. And so like I was saying a few slides ago, there are ports associated with a machine. And so if you make a request, say to like port 80, that's usually used for web traffic, right? So if we want to see if a machine has a web server, we could just try making a request to port 80 blindly. And there may or may not be a web server there, who knows? But in this case, we made a request to port 80, and it turned out that this server was actually running a web server. But it could also be running other services like Minecraft or something like that run on port 25565, for instance. And so if we made a request to the same IP with a different port, with the Minecraft server port, then we could get a different response. And so the basic gist of this is that the port number determines which service gets a message. So like each port generally has a couple pieces of software that are generally tied to it. So like port 80 is almost always a web server, and port 25565 is probably going to be Minecraft or something. And so once we have that information, the basic idea of what we're going to do is take an IP, just check port 1, check port 2, and so on, and basically just send messages to every port and see which ones get a response. And so like this was a web server, for example. So we didn't get any responses from port 1 all the way through port 79. But when we made a request to port 80, we got a response. And so now we know that it's probably running a web server. And then based on the response, especially if it says, if we make like a get HTTP request or something, we just make like a normal web request, then the server will normally respond and say like, oh, 404, this page doesn't exist. And then from there we know, oh, okay, it actually is running a web server. And sometimes it'll even tell you, hi, I'm in the server header, or the server header, for instance, it'll tell you, I'm an Apache 2.4 server. And then now you know exactly what software they're running, you know what version they're running. And so by using port scanning, you can identify what software a computer is running. And a lot of times you can also tell what version exactly it's running. And so once you know that a computer is running a specific type of software, right? So like this computer, for instance, let's say it's running the normal Windows file share, which is done over a protocol called SMB, which is usually on port 445. So if we were port scanning and we checked 445 for Windows file share, and it gave us a response. Now we know this computer is running Windows file share. So there's this exploit called Eternal Blue that the NSA discovered and was leaked, which basically lets you, for older versions of Windows file share, or the protocol that it's running on, you can exploit it to get remote code execution. So what that means is basically you send some like super specially crafted malicious input to the service, the software, and that allows you to take control of that service basically and execute any code you want. And so for instance, we could like set up a reverse shell, or we could download a piece of malware from our computer or something like that. And so once we have remote code execution on their computer, we can do whatever we want. We can like look at what files they have on their computer. We can take information from their computer. So there are tons of examples of that. Like WannaCry was based on this exploit, basically. So there was a group of hackers, basically. I think it was originally from like a advanced persistent threat group in Russia. But basically what they did was they just scanned the internet for computers that had this Windows file share, an outdated version of it, and they just used the Eternal Blue exploit, which was accidentally released by the NSA. And they used that to come up with a specific attack called WannaCry, which was just a piece of malware that would encrypt all your data on your hard drive, and then you had to pay them to get your data back. And actually 200,000 computers on the internet were impacted by that. So even though we knew that this Windows file share version was out of date, tons of computers will still run out of date software because people don't realize that they need to update their software, or they just forget about a server that's been running. And so that leads to tons of vulnerabilities, and port scanning and service exploitation is basically the way that, that people take advantage of that on the internet. All right, so thanks for coming to the talk. Feel free to hang out and ask questions. Yeah, as Alex was saying, there's this